Hello again. I got another question from a student about section 6.1 problem. That problem is about confidence interval for the mean. So as we know, the confidence interval are calculated when you have one of the parameters out of the two usually. Uh, the mean uh, and knowing the other parameter like uh, sigma or standard deviation. So we have the other way around that we are going to learn when the mean is known and we want to find a confidence interval for the sigma. So let's get into that quickly. So let's say you have calculated, you have a sample a population, all right? So you have a bunch of data, 7, 9, 20, 30, etc. So you want to find the population mean rather than the sample mean, or with the sample statistic x bar is calculated. So the value, a single value estimate for a population, we call it point estimate. So most biased point estimate of the population mean mu is actually the sample mean x bar. Most unbiased, I'm sorry. So possibly that's best. So here's an example of the data that we have. 40 employees, the number of hours they work by 40 employees are here in several grocery store. Find a point estimate of that. So actually we use data, statCrunch to calculate these, but you add them all together and divide by 40 to get the number of hours on average in that grocery store people work, right? So this means that employees in this county work 29.6 hours on average. So, but we would like to have an interval estimate, all right? So interval estimate would be, we say all the workers, we are confident 90% that they work between, let's say, 20 to 40 hours or something like that. So we have to express two things given a percentage of confidence interval. One is the interval from what number of hours to what number of hours, and say, what's the confidence percentage. So of course, the wider the interval, the higher our confidence will be. The narrower the interval around some value, the less likely that is true. So that was about interval estimate that we learned. So an interval or range of values used to estimate the population parameter. So this is just an example, not relevant to the last example. So x bar is that. So we go some amount to the right, some amount to the left. Then we say we are confident with some percentage that the mu or population average is around that. So that's we're gonna say how confident we are in the interval that contains the population mean mu. So that's the key. So interval estimate. So we know that we can use if we have a normal distribution, that usually is the probability that the interval estimate contains the population parameter is actually a normal random variable. So C is the area under the standard normal curve between the critical values ZC and Z negative ZC, and we use basically want to have the total value of the total area equals to 1. So this is C. The area on the left and right together is 1 minus C. So half of this here, one half of the other one is 1/2 of 1 minus C on each side. So we call these critical values, right? And C is the percentage that we have. So the remaining area in the tail is total 1 minus C. As an special case where the level of confidence is 90%. This means that 90% confident that the interval contains a population mean. So it should be pretty large interval from, actually this is gonna be from negative 1.6 to positive 1.6 roughly, because when we have 90% here, right? So 0.5% will be here, and 0.5% if you all right. Now if you look at, you want to find a corresponding value C for which we have actually area 0.05. So we need to look in here in the table to find 0.05. So 0.02, 0.05. You see that? 0.052. We're getting smaller and smaller. So it's gotta be between negative 1.6 for something. So actually 0.645 is the average of these two values, as you can see in here, right? So look at that, negative 1.64. A publisher wants to estimate the mean length of time in minutes, right, of all adults spend reading newspaper. So in this case, they randomly select 15 people, and they found this result, and publisher knows that the sigma is 3.2, maybe from past experiences. So the population of times is normally distributed, so this is a fact that we need to be able to use z-score and all that. Construct the 90% and 99% confidence interval. So which one is wider? Obviously 99% is wider, and we can use the technology, but let's do it without technology first. Find the left and right endpoint. All right, so we use this formula to find the margin of error. All right, the margin of error is basically ZC times sigma over root n. C is 90%. All right, so and then we have ZC is the z-score of that. So for 90%, ZC will be what? Negative 1.645, as we had when we're doing the slides. We're studying these slides. So we have E then, because we have sigma, we have n equal to 15. Sigma is here, multiplied by ZC, which is negative 1.645. We get what? We get E. So the left end point of the confidence interval is x bar minus E, and the right end is x bar plus E. All right. So to continue, first we find for 90% and then 99. So the level of confidence is C is the area under the standard normal curve from negative ZC to ZC. The area outside of it is 1 minus C, right? So the area on the left tail and right tails are the same and equal to 1/2 of 1 minus C, as we had on the slides too. So C is 90%, so 0.9 in other words. We get 0.09 is the Z, actually is the value that we need to find. So the standard normal table tells us that for the tail area of 0.05 is 1.645. Is that right? The positive critical value that we can find. So we make that positive, in other words, this value. Otherwise, actually, is negative. So EC is 1.645 times 3.2 divided by root 15, or 1.45, right? So it's E is 1.14. So now that we have this value, we need to find X bar. X bar is 9.2. We just add them and divide by 15. Like I said, you could use statCrunch and come up with this 9.2. Go to just stat, summary of the column, select that, the mean, you get 9.2 as it's here, right? So finally, we need to add and subtract E from 9.2 to get the confidence interval. We do that, subtract, get that, add this. Now we can state that with 90% certainly the population mean falls into this interval. Right, so let's solve same type of problem now using a statCrunch or technology. So first thing we would like to do is, so same thing, 15 number of people, sigma is 1.8, and maybe the numbers are a little different, but I want you to see how we can do this with statCrunch. So you click on the data, you can open in Excel, but we would like to open this in statCrunch. Then you do a stat, alright, click on the stat, then you go to calculators. From there you go to normal, because remember that's a normal distribution, right? Now you need to select the between option that you have here. Choose between. Then we would like to specify, we need to specify the level of significance, so 0.90 or 95. So here we need to specify that. So here we have 0.90. All right, and then we would like to see what is the upper and lower limit, right? So these are the values that we get, right, as we expected. Negative 1.645 and to 1.645 to positive 1. All right. Now, once you have these values, the upper limit is the critical value. All right, and then we multiply. We use this in our calculation to do that. So let's do this here. So the mean, we can also calculate the mean. Let me close this one up because we have the value. Calculate the mean. Stat. You can calculate the mean differently, but we can go to stat, the column, or we can do another way. We can do z stat, and let me close this one up, it's on our way. Stat, then you go z stat, one sample with summary. So the sample mean, let's calculate this, it seems like it's needed. So we go here, stat, the column, let's get the mean. So 0.953333. So I'm going to copy this, go back again, one sample with summary. That was the mean. Standard deviation, what is it? 1.8, 15 people. statCrunch go? So 1.8. And sample size is 15. So we need to have a confidence interval from 0.9. So interesting. Now we have the sample mean, as you see here, that we gave it to that standard error is that. Now left and right, 8.76 and 10.29. Let's see if the answer is the same. So I'm gonna say help me solve this, maybe. Moving forward, for 90% is 0.9. Guess we have to do it again. So here, this time will be 0.05 again. CC is a positive critical value, 1.645, was it? Does it say up to some number of digits? And then you multiply that, use a calculator. So let me get a calculator here. Calculator. Get the scientific one. So it is 1.645 times 1.8. Is that divided by square root of 15? Square root 15, square root of that down to the division. I hope this is correct, but we'll see. 0.76 will be around to 1 decimal place. 0.8. Okay, let's look at the statCrunch. So we need to find this. Look at the statCrunch again. Do it faster. 9.53. Round to 1 decimal places. Should be this. Good. Now subtract 9.5 from that. You get 8.7. Right? So 8.7 is actually recorded here, and the other one is 10.2. Actually 10.3. Up to 3 decimal, 1 decimal place. 10.3. So as you see, the results are correct. This is the interval width in the theory, and then this is with the technology. So you see that they are the same. So it was one more time how to do that. What we did was we went to z-stat, which is normal. Then with summary, we calculated the mean 9.5 something. We are given these, and then we set the confidence interval to the desired one, and we calculate. So I hope this was helpful.